Electricity. Life is electric. Did you turn on a reading light before opening this book? That is one way to start learning about electricity. Electricity is everywhere. We use it for light, for heat, and for sound. We cook with it. It powers our computer. It keeps our food cold in the refrigerator or freezer. If you use an iPod or MP3 player, you use electricity. Do you watch TV or talk on the phone? If you do, you use electricity. Positive and negative. Electricity is a kind of energy that flows through material. It starts in atoms that make up everything around us. The structure of atoms help make electricity. Atoms have tiny particles called protons in their center. Protons have positive charges. Tiny particles called electrons circle around the edge of the atom. Electrons have negative charges. Opposites attract. The key to electricity is that opposite charges attract. The electrons and protons are attracted to each other. They are like the opposite ends of a magnet. When close, they pull together. When an electron moves away from an atom, it searches for new positive charge on other atoms to connect to. When electrons move from atom to atom, they can be directed into streams we call electricity. From power plants to home, electrons travel easily through certain material, like some metals. We can guide electricity through this material. Electrons can travel for hundreds of miles through the big power cables from power plants to home far away. When you flip on a light switch, streams of electrons pass through the base of the light bulb. Your light comes on because these electrons power the bulb. Shocking! Electrons are in everything because atoms are in everything. So electricity doesn't just run in wires and cables we make. It occurs in the nature as static electricity. Static electricity causes you to get in little shock sometimes after walking in a rug. It also causes lightnings. We live in a great big field of electricity. Life would be impossible without it. Chapter 2. Circuit. Electricity powers things at your home in a simple loop. A wire carries electricity from power source to the thing being powered, then back to the source. This loop is called a circuit. Think about a flashlight. A flashlight uses a circuit. It uses metal wires and battery to create a loop. Wires go from the battery to the bulb and back to the batteries to complete the circuit. Switching on, switching off. The key to a flashlight circuit is the switch. It separates the wires when it is in the off position. When it is on, it pushes two ends from the wire together. The circuit is closed when the switch is on. Then electrons can flow through the circuit. They pass through the wires and through the batteries. They follow the circuit and run through the base of the bulb. The light goes on. If you turn the switch off, you disconnect the wires. The circuit is opened, and the bulb goes off. The light and powers in your home operate the same way. The electrical circuit is open until you turn a light switch on. At power outlets, the opening are where a circuit is open. Pushing in the metal prongs of a plug closest to the circuit, electricity runs into your power cord. Insulators. Power cords are often coated with plastic or vinyl. The atoms in plastic or vinyl have electrons that stick well to the atoms. Wood, glass, ceramic, and fabric have similar sticky atoms. They all make good insulators. Electricity does not move well through them. Insulators are used to cover flashlights, wires, and power outlets. Because of insulators, you can touch these things without getting shocked. Conductor. Most metals have restless electrons. The electrons move away from the atoms pretty easily. Loose electrons flow well through metals. We call materials such as metal conductor. They conduct or move electricity well. That's why we use metal wires in electric cord and cables. It's why flashlights have metal springs that hold batteries in place. Electricity easily moves through metal wires and metal springs. Direct currents. Batteries, like magnets, have a positive end of a negative end. A flashlight won't work if the batteries are not lined up properly. What happens if the positive ends of the battery is pointing toward each other? The electrons will bump into one another and stop. We line batteries up so that positive ends of one battery is touching the negative ends of the other. Then electricity can run in a direct current.